In a previous video, we talked about whole number addition properties. And in this video, I want to review those properties briefly and then walk through a couple of the examples that I've placed in the notes, in part because I think I'd have questions about them. So I just want to kind of walk them through and explain what they're about. So the whole number properties that we're covering, at least in this class, there are other properties, but here are some of the primary ones. One is the closure property. If you have two whole numbers, a and b, and then the sum, a plus b, is a whole number. The commutative property, which says if a and b are whole numbers, that a plus b equals b plus a. So it doesn't matter if you take 4 plus 7 or 7 plus 4, you get the same result, which is 11 in that case. The identity property says that there is an identity element, which is 0. And so if a is any whole number, then a plus 0 equals 0 plus a, which equals a. So if you add 0 to any number, you get that same number back. 3 plus 0 equals 3. Lastly, the associative property, which is sort of a subtle but a very important one, indicates that it doesn't matter the order in which you add, essentially. So if you have a string of numbers, you can take a plus b and then add c, or take a plus b plus c. So the order of addition is irrelevant. Anyways, or you can group the numbers in different ways and get the same result. So again, I'm not going to introduce new problems, but just talk through a few things that are outlined in the notes. The first one is I'll call mental math. All right, so mental math is something that is pretty common in elementary schools. And what you start with mental math is you start in addition. You start with properties of 10. And then adding values to 10 is quite easy. 10 plus 8 is 18. 10 plus 2 is 12. So students might have a difficult time remembering 9 plus 5, for example. And so what you can do is you can actually break this up. You can say, okay, well, 9 plus 5, I'm gonna break up 5 in a convenient way. So 9 plus 5, I'm going to call 5 1 plus 4. And that would be considered an addition fact. And then, and here's where the associative property comes in, that equals, I'm going to regroup that, 9 plus 1 plus 4. So I regrouped 9 plus 1 plus 4. I regrouped the 9 and the 1 plus 4. But 9 and 1, again, is an addition fact. That's 10. 10 plus 4 is 14. Similarly, if a student wants you to do 8 plus 7, or if you ask a student to find the sum of 8 and 7, then again, you don't need to necessarily break up the latter of those two addends. You can break up the first one. You can say, well, okay, 8, that's 5 plus 3. And you might think, okay, well, how do you come up with 3? Do you pick it out of a hat? No, what I'm thinking is, what can I add to 7 to get a property of 10? So 3 plus 7 is 10. So I know that 8 is 5 plus 3. Okay, then I regroup with the associative law from here to here. I say, okay, well, that's 5 plus 3 plus 7. But 3 plus 7 is 10. 5 plus 10 is 15. Now that's in base 10. You might find this in this class. You might find this helpful when you're working with other bases. So here are a couple examples. I'll walk through one of them. They're in the notes. Let's look at 4 plus 4 base 5. Okay, so 4 plus 4 base 5. And so if I want to get a 10, if you will, well, I know that 4 plus 1 in base 5 is equal to 10. It's equal to 1 5 and 0 1s. So I'm going to break up this ladder 4. I'm going to say, well, that ladder 4 is 1 plus 3. Again, why did I do the 1 and the 3? Because I want to add 1 to my 4 to get 5, which is 10, right? 5 is 10 in base 5. So I use an addition fact here that 4 base 5 is 1 plus 3 base 5. Then I use the associative property, which is true in any base. That equals 4 plus 5, grouped together, plus 3, which is 10 plus 3. Okay? Because 4 plus 1 is, again, 5, which is 1 5 and 0 1s. 10 plus 3, well, that's something that is pretty easy to do. That's the same as in any base. That's 13 base 5. So you might find that this application of number properties is helpful with other bases. So let's work one more. Base 7. Okay, so base 7. I'm going to take 5 plus, let's say 5 plus 4 in base 7. And what would that equal? All right. Okay, well, 5. I want to get, in base 7, I need to get a 7. That's how I would trade up. So I'm going to break up 4. I'm going to say this is 5 base 7 plus 2 base 7 plus 2 base 7. So that's just an addition fact. 4 is 2 plus 2 in base 7. Well, now I'm going to regroup using the associative law. That's going to be 5 base 7 plus 2 base 7 plus 2 base 7. So I regroup so that 2 and 5 are together. But 2 and 5 is 7, and 7 is 1, 7, and 0 ones. So that would be equal to 10 base 7 plus 2 base 7, which is equal to 12 base 7. So 4 base 7 plus 5 base 7 equals 12 base 7. Final problem using number properties is when you're doing mental math with larger numbers. And again, what I'm trying to do here is not say, well, this is how you want to teach it to students. What you would do with students with mental math with larger numbers, this is why I called it number properties 2 in mental math, is you would tell the students, okay, group your 10s and group your 1s. Okay, 40 plus 10 is 50, 2 plus 7 is 9, 50 and 9 is 59. So that's how you would go about with students. But here's a true mathematical justification. So follow the steps. I'm going to take 42 plus 17, and I can write each of those in expanded form. 40 plus 2 plus 10 plus 7. Now, and this is where it gets a little tricky, I can use the associative property. I've got 40 plus 2, I think of that as one thing, plus 10 plus 7. I'm going to regroup that. So you have 40 plus 2 plus 10, and that's actually a missing parenthesis there. So what I do is I associate the 10 with the 40 plus 2 plus 7. So that's the associative property. Now I'm going to group within this bracket here, I'm going to group the 10 and the 2. So that's again an associative property. 40 plus 2 plus 10 is equal to 40 plus 2 plus 10. So that's the associative property again. Now, again, what I'm trying to do, this basic idea, group the 10s, group the 7s, or group the 1s. How do you know you can just move those things around? That's the question. Well, now that I have 40 plus 2 plus 10 right there, I can commute the 2 and the 10. That's allowed as a commutative property. So that was going to equal 40 plus 10 plus 2. This is looking promising. That's the commutative property. Because now I can reassociate 40 plus 10 plus 2. I can associate the 40 and the 10. That's how you group your 10s. Plus 2. Lastly, use the associative property again to group your 10s, group your 1s. So that is 40 plus 10 is 50. 2 plus 7 is 9 equals 59. So when you say group your 10s and group your 1s, there's a whole lot of steps behind that. Okay, so in this class, I will probably ask you at some point to recreate with other numbers something like this, understanding how each of the number properties applies and allows you to group your 10s and group your 1s.